So the alternative is this, a very simple change. We take this out and say, no, that's too late for C++. And C++ supports the so-called member initializer list. All you have to do is use colon, that's part of the syntax. After the constructor declaration, the constructor header line right here, the name of the constructor, the list of parameters, the parentheses, you use the colon, and then you write this code outside of the constructor body, because this syntax will be accepted as something that those values will be used when the object is actually allocated in memory. So this will be much more efficient rather than doing this inside the constructor. Believe it or not, this may seem to look like something that is insignificant. I don't know how to name it. But it is significant given that there could be thousands and thousands, sometimes millions of objects constructed. In the situation where you're dealing with millions of instances of objects, then you're losing a lot of time, not taking advantage of the member initialization in the member initializer list, because you're actually constructing object with garbage and then populating it with some useful value. So for this, there's this very special syntax, and unfortunately you cannot use assignment syntax. Instead, it's more like a constructor syntax, and it's named list for a reason that you cannot use a semicolon. You have to use a comma to separate those things. So this is how member initialization will look like using initializer list, right? There should not be semicolons used. There's only one colon at the beginning, and you use parentheses to use a constructor-like syntax to provide the initial values for your data members. So it's very important that at some point, you know, I cannot cover all of this. It'd be great if I just said, okay, today we're going to talk about constructors and we're going to cover everything related to constructor syntax. All right, so unfortunately it's present to multiple presentations, and today finally, since it does show up in our next presentation, it's time to talk about the initializer list. Now I will tell you this, I would never write statements like this in my code. I will routinely always not even think about this. This is, by the way, this is what you would write in your Java program. Java program does not support initializer list. Java syntax essentially tells you, you write this code, but the compiler will optimize it and basically make sure that it gets populated with those values. In C++, unfortunately, this is not automatic, this is not instant. What has to take place is that you need to remember to use the initializer list syntax to make your constructor as efficient as possible. Now, just for a second to demonstrate, let me go back to the Terminator. So let's say open recent projects, right? So we have the Terminator here. In case of the Terminator, I will give you this example. See how I have pointer initialization. Well, of course, this is what I would normally write. The constructor is, the body is empty. Instead, I'm using the initializer list. I'm sorry, I'm trying to type it. And so the initializer list in this case will look like this. Okay, so replacing this assignment inside the constructor with initializer list, because this should be your habit. This is how you write constructors in C++. You use initializer list whenever possible, because there is a reason there. Because those initializer lists are actually used when the objects are allocated in memory, so no CPU cycles are wasted for doing that, and then in some separate steps, basically for initialization of data members inside of our classes, doing it inside the constructor body is too late, is too inefficient. Similarly, over here I could replace this statement with initializer list. So I will actually keep this one in view. Instead, again, I will just copy and paste the syntax right here and say new int. So I'm creating new int, new returns back a pointer. I'm capturing this point and immediately initializing my member data pointer with this value. Again, the initializer syntax. And that's about it. I just wanted to show you how I would actually write this code if I was writing it from scratch and not giving that previous presentation. I would definitely guarantee using initializer list to initialize any data members right here. A side note on this topic is that if I decided to add something else, I don't know, double, I don't know, stats of some sort, keep statistics here. If you add another variable, you must immediately revisit every constructor, and in particular the initializer list, and perhaps decide to say, well, okay, we have the new data here, so let's not forget about it and actually initialize it with something meaningful. Just like that, right? Just because you added brand new member, you have to revisit each constructor, and perhaps for now just do this. Initialize it with something, and you have to remember to use comma. When you have a list of multiple pieces of data that you want to initialize, you have to use comma to create this list. It's not a semicolon, it's a comma. So it's slightly different. And colon is at the end, at the beginning. Some people, different styles exist. I prefer to do it this way because it's kind of visible and easy to interpret. But a lot of textbooks would be doing something like this. Just do it all in line. You know, I mean, again, if you find this to be more readable for your own liking, go ahead and do this. But I actually prefer something like this, to go kind of vertical on those things. All right, so let's save that and quickly switch back to our other project, which was linked list. So here's much simpler example. So here's class node. I don't know if it's simpler, but it's yet another example. So we have data attributes. This guy is private. This guy is public. We create constructor which takes an integer value, which is the actual payload for our node, right? So I can construct another node, something like node B right here, and store other values in there, like something like that, right? Doesn't matter. So this is our first step. So here clearly you can see member initializer list, and that's the look and feel. There's absolutely nothing strange about those lists. We use them because this is a way to efficiently, in fact, as efficiently as possible, initialize the data members of our classes. Also, C++ standards has certain requirements, such that, for instance, if you have pnode declared right here at the top of your class, and the data happens to be following it, it would not be a good idea to do it this way. For example, GNU compiler, the open source compiler, will say, no, the member initializer list is out of order. Because in reality, the data fields are constructed exactly as they appear. If you recall our talk about construction and destruction of C++ classes, what happens is that when you create a class, the sequence how you position data members in your class definition has direct impact on the sequence of how these things are constructed. And so member initializer list supposed to follow the order of that. Unfortunately, and I don't know why, I need to research this. If I go to my build and say, okay, build this solution, right? Compiler really doesn't give me any warnings here, but let me try this. Project, right? Go to properties, go to C++, and go to let me see, language code generation, maybe looking for a level of warning. Treat specific warnings as errors. It has to be somewhere here. Disable, compile, show, use path. Let me save this because I'm wasting